Unit 2 test on Wednesday. The first part of your homework, what is it? Well, study always, but journal entry. How's life? How's math? Put it away. Don't do it now, of course, but that's the first part of your homework. Make it a nice one since you actually have time at home to do this. Spend a little bit of time on that. Give me as much as you feel comfortable with. And any questions on this one right here? Any questions on this one? You like multiple choice questions like this? If I give you multiple choice questions, you will have to justify your answers. Only one third of the credit will be getting the answer at most. Most of your credit will be given to the work itself. So you could explain all these things pretty well? Okay, that's fine. So let's say that again. What's the first transformation is a translation. So what does translation mean?
Moves.
It just moves in a what? A curve? In a straight line. So we're translating it along a straight line. And then it says, followed by a reflection in a line parallel to the translation vector. So if that's the translation vector, maybe it moved it from A to here. Here's A prime, B prime, and C prime. Is A prime, B prime, C prime congruent to ABC? Yeah, we know that triangle ABC is congruent to triangle A prime, B prime, C prime. A translation is an isometry because it maintains congruency. Isometry means a transformation that maintains congruency. Do we still have congruency? Yes. Translations are isometry. So, and then it says a reflection in a line parallel to the translation vector. So if we draw a line, let's say is that these two are parallel. This is parallel to this. And we reflect it. Here's C, A, and so there's A double prime, C prime, and B double prime. Sorry, B double prime. So the question is, if you wanted to go straight from here to here, what type of transformation is that? Any ideas? Is it a reflection?
Rotation. Because it's staying on a straight line, so it would be
Well, is it staying on a straight? It's staying on a straight line from here to here, right? And then it's a reflection. Let's make it smaller. Let's do a smaller example. Let's say I took, I don't know, goes up like this. Here's one. So here's A, B, and C. I'm going to slide this up and over 3 units each way. So we're going to go up 3 over 3, up 3 over 3, and up 3. Sorry, I didn't do that right. Up 3. There's C prime. Here's B prime. And up 3 over 3. Here is A prime. So our first transformation was this right here. Up 3 over 3. Do you see how I got from one to the other? That's a slide. It's a translation. Now, let's reflect it over a line parallel to that vector, parallel to up 3 over 3. So how about this one right here? Here's this line. Is that parallel to up 3 over 3? Yeah, it looks like it. So now we need to reflect this. What's it going to look like? Here. Here, so that's A double prime. That's C double prime, and there's B double prime. Are we okay like that? So what does it look like you did? How can we get straight from A to A double prime? Is it a rotation? If you wanted to go from here to here. Looks like it's a translation. How much? How many units on that one? How many units is it from A to A double prime? Count. How many units is it? 1, 2, 3, 4, 5, 6. What about from C to C prime? 1, 2, 3, 4, 5, 6. What about B? Is there a problem with B?
It's like...
If you went over 6, where is it? 1, 2, 3, 4, 5, 6. Is it almost?
Almost.
It looks like it's really close. If we did that, it would be here, here, and here. It's almost it, right? So is it, by this example, is it a translation? No, it's not a translation. By this example, it's not a translation. Glide really mean translation. It's a glide reflection.
So it's just...
That's what they're asking you for. They just want the name of that term. So it says, if the distance between K and M is 5 units, so from here to here is 5 units, what is the distance between the corresponding part figures R and R prime? So so this goes from here to there. That goes from here to there. I should do different colors, shouldn't I? So that's a corresponding part. And let's draw another one. Blue to blue. Anybody have an idea here? It says, if the distance between K and M is 5 units, what is the distance between corresponding parts of figure R and R? Oh, R double prime. I'm sorry, I'm going to the wrong one. R double prime. Here and... where's that one? Blue? What does it look like? It looks like it's 10. Why does it look like it's 10?
Because it's 5 in the middle and there's like half on each side.
Kind of looks like it's half, but is it always half?
Yeah.
Let's think about it this way. Let's draw 1 point. So if these are 5 apart, 1, 2, 3, 4, 5. And let's say I reflected this twice. And at first, let's put it at 2 away. So that's 2 away. If I reflect it, how far does it become away? 2. This is 3, so it's going to go 3. You have 2, 2, 3, 3, which is 10. Let's start even far. Let's start farther. Let's start from 5 away. If this is 5, it's going to reflect where? To there, right? And then if you reflect and it's already on the line, is it going to go anywhere? No, it's going to be on their line, so it's going to be 10. What happens if it was 1 away? How far would it reflect? 1, and then it would. This is 4, so how far would you go? 4. Does that make sense?
Can we do farther than 5 away?
Let's see what happens if we do further than 5 away. Let's see what happens. Can you not rustle with your papers left field? Buy a binder? That'd be great. Let's go to, I don't want to go to 7. So if we go to 7 and we reflect it, where's it going to go? To there, right? But then if we reflect it back, we have to reflect it again. Where's it going to go? It's going to go right to here. How far is this from here to here? So, I'm sorry, I'll do the other side. It's from here to here is 3. So how far is it away? Here's R and here's R double prime. Is it still 10? It was 10 the entire time, every time we did this. Is that... So do we believe it's going to be twice the distance between these two?
Yes.
Is this proving it, though? We believe it now, right? If we had come up with something other than 10, we just proved it's not always 10. But we have 4 examples that leads us to believe it may be 10. So let's do an example of this. Let's try this here. Instead of saying 2 or 7, let's say it's distance of 1, 2, 3, 4, 5. Let's say it's x, not 3, let's call x away, like this. If we reflect it, how far is this distance going to be?
2x.
Well, it's going to reflect x, so the whole distance is now 2x, correct? You agree with that? If that's x, what's this distance going to be if this whole thing is 5 right here? This is 5 minus x, correct. And then if we reflect it again, how far is it on this segment right here? 5 minus x, again, because we reflected 5 minus x. Do you agree with that? So we have x, x, 5 minus x, and what's x plus 5 minus x plus 5 minus x? What cancels? And what are you left with? You're left with 10. Let's make it even more general. Let's make it more general. Instead of 5, what do we want to call the distance between the lines? What? Y? Sure. Let's call this distance y. So let's call this distance right here x. If we reflect it, how far across that first line are we going to be? L1 and L2. It's going to be x across, right? Oh, that's nice. What's this next distance here going to be? Y minus x. And we go another y minus x. So let's add them all together. X plus y minus x plus y minus x. What does that equal? 2y. So a double reflection across parallel lines, what do you end up with?
2y.
You travel the distance to 2y. Is that a proof? Yeah. Can y be anything you want? Can x be anything you want? And on this case, Will, you asked when we did 7, it went past it, right? You'd be putting in some negative numbers. So instead of going past it, you'd be 3 behind it, but it was 7. End up with 10. Pretty cool? That's pretty neat. I think that's pretty neat. The lines have to be what, though? Parallel. Do things get really wonky if they're not parallel?
Yes.
Yeah, the formula's going to be a little harder to do. A little harder. Because it's not going to be moving in a line. It's going to be like going over and then over here, and you're doing this distance. And if it's not a right triangle, is your life kind of hard? Yeah, do you really have any idea? If you need the coordinates. Okay, 9 says, use the diagram in which lines M and N are lines of reflection. Number 9 said, if the measure of the acute angle between M and N, so that which angle is that going to be? It'll be right here. Acute means what? Less than 90? Yeah. What is the angle of rotation from figure T to T double prime? So you're going from T to T double prime. We did a question like this. Does anybody remember when you reflect across two intersecting lines, what's the rotation actually? Do you remember this?
No,
What is it, Jackmo? Or what is it?
When you're,
What's the angle of rotation going from T to T double prime? What is it? It's 180. Do you remember we did this and you measured it out? This was one of the questions you did 2 homeworks ago, I think. Am I right, Hammer? Any 2 lines, right? If you have 2 lines that intersect like this, there's a different angle, right? If I reflect this over this, I'm going to get that, right? And I'm going to reflect it here. Ooh. Did that work? So we went from P to P prime, and then P to P double prime. Uh-oh. Is this 180 degrees right here? Is that 180? No, it's not. So I'm wrong. It isn't 180 degrees. Or I thought it was supposed to be 180 degrees. Ah, is it 2 times the acute angle measure? It is? What do you think?
Yes.
Is it? Yeah, so we think it's 2 times 85 degrees. So it equals what? In this one, 170. In this case, the acute angle measure, is this 85 degrees? No, it's less than 85 degrees. So what's this whole thing going to be? Twice that. It's going to be twice that. So it's 2 times the acute angle measure. 2 times.
Is there a reason that I wrote degrees south?
I don't know. I do not know. So what that means is we're looking at, we know that this triangle right here is congruent to that triangle. So this angle here is congruent to that angle there. We know that this triangle is congruent to this triangle, that side angle side, the same thing. So this angle is congruent to that angle. So if these triangles are congruent, you know that this angle, the top angles are congruent here, and these 2 angles are congruent here. So how many of this angle do we have? 2 of them. How many of this angle do we have? So the whole thing has to be twice the central angle. That's very good. Awesome. Very, very good. So if you reflect twice across 2 intersecting lines, you've really just rotated by twice the acute angle.